An equilateral triangle has three sides of equal length. Copy it. Flip it. Reduce size. Now we have 4 equilateral triangles. Repeat the steps for each of the dark-colored triangles. Repeat again. And again. This fractal was created by subdividing an equilateral triangle recursively into smaller equilateral triangles. A number is formed by adding 2 preceding numbers. When this is applied recursively, a Fibonacci sequence is formed. Recursion is implemented as a function. It calls itself within the function, each time with the successive version of the problem. As shown, this function calls itself infinitely. We don't like infinite recursion, so let's place a stop condition. Now the function calls itself, only if p is greater than 0. When p becomes 0, the function stops. And the program retraces its steps backwards. Let's place a print statement, so that we can see the program retracing its steps. The print statement runs, after returning from the function call. Now let's see how we can generate a Fibonacci sequence. A Fibonacci sequence begins with 0 and 1. The next number is the sum of 2 previous numbers. This means, our recursive function accepts 2 input parameters to generate this number. Here is our function with p1 and p2 as input. It prints the next Fibonacci number, the sum. And then it calls itself, to generate the next number in the sequence. The question is, what are the 2 input parameters? So far we have 3 numbers in the Fibonacci sequence. The next number is the sum of this and this. So we need to pass in these 2 as parameters. And here is the updated function. Let's test it out. The function accepts 0 and 1 as parameter, prints the sum, and then calls itself with 1 and 1. The function accepts 1 and 1 as parameter, prints the sum, and then calls itself with 1 and 2. The function accepts 1 and 2 as parameter, prints the sum, and then calls itself with 2 and 3. The function accepts 2 and 3 as parameter, prints the sum, and then calls itself with 3 and 5. This seems to work as intended. Only the function calls itself infinitely. So we need to add a stop condition. With this conditional statement, the function stops calling itself after 5. Let's see the recursion in action. We begin with 0 and 1. Call the function with 0 and 1 as input. Print the sum. The sum is less than 5, so call itself with 1 and 1 as input. Print the sum. The sum is less than 5, so call itself with 1 and 2 as input. Print the sum. The sum is less than 5, so call itself with 2 and 3 as input. Print the sum. The sum is now equal to 5, so the function stops. And the program retraces its steps. And we are done. As you can see, recursion provides a simple and elegant solution to the right kind of problem. The downside is that it uses a lot of system resources. That's a whole new discussion for another video.